What if I told you that one simple technique that can solve more than 30% of array and string problems on LeetCode? It's called as a two-pointer technique or two-pointer pattern. If you master this technique or pattern, problems like two sum, container with most water, and palindrome checks become much easier. Today, I'll teach you every variation of this two pointer pattern in Java step by step. Welcome back to my YouTube channel Code with Dharamveer, and welcome back to the lead code patterns in Java series, where we break down the most important coding interview questions or interview patterns used by top tech companies in the video. uh, in the video will cover what the two pointer technique is, when to use it, all major variations, and real code examples with clean Java implementation. So let's begin here. Now, the thing is that the most beginners try to solve the problems by using nested loop, which gives the time complexity as big O of n square. But the interviewer expect the time complexity as big O of n. So the solutions, whenever it is possible, right? So interview is expecting big O of n, and you're solving or you are giving the complexity as big O of n square. That is a big problem here. So instead of scanning the array twice, we use two pointer technique to move strategically one pointer that starts from the left and another pointer that starts from the right. So when to use this technique? Whenever you see the pairs problem or sorted array or symmetrical comparison, your brain should immediately think of the technique called as a two pointer pattern. So that's how you need to recognize the problems that are available in the lead code. Now, this is the two pointer technique. The concept is that we are going to use the two pointers here, one from left and one from the right. So you might be given a one array, and then you have to use the two pointers here. So let's quickly begin with how the first variation, or you might have the variations that will you encounter in the two pointer template. So let's quickly move on to the two pointer template. So I'll open the whiteboard for you. So let's start with this. So I'll show you the two pointer template. So which template? That is a very common template, that is a two pointer template. So quickly begin here with the two pointer template. Right. So you need to take one pointer, that is int left equal to 0, right? And then int right equal to array dot length, whatever the array you have been given. So that array dot length, right, -1. Okay, so that will become your right pointer. Okay, now the thing is that you need to apply the condition. So you, for that, you will use a while loop while left is less than right. Okay, so you will use this while loop and you will apply some condition here. So if condition, right, if some condition, then if the condition is met, then what you will do, you will increment the left pointer left plus plus, right? And if the condition is not met, so what you will do, that you will use else condition, and you will use you will decrement the right pointer, right minus minus. Okay, so that would be giving you the, this is basically the template, that is the template, right? So that you need to close the braces here, and then the while loop brace here, right? So this is basically the template. So this is the two pointer template. You will be having a first pointer left equal to 0, then the other pointer right equal to array dot length minus 1, and you will apply the, you will traverse through the that condition. That means you will apply the condition left is less than right, and then you will apply inside the loop, you will apply the condition. So if the condition is met, you will increment the left pointer. If condition is not met, then you will decrement the right pointer. So this is how the two pointer template is. You need to keep in mind. It's very important. Okay. Now almost this every two pointer problem follows this structure. You need to move the left pointer, right, right pointer sometimes, or both. So it might be possible that you might be moving both the pointers as well, right? So we'll encounter such kind of things as well in the coming sections, right? Now let's quickly move on. So I'll go to the right. So this was the basic template of the two pointer technique, right? Now this is what I have told you, right? This is a core template we have just seen. Now the first variation is that uh, opposite direction pointers. So the first variation comes the opposite direction pointers. Now in this, what happens is you are having two pointers, like, and both would be moving in opposite direction. So you will encounter the problems like to sum to in the LeetCode. Okay, so whenever you encounter such kind of problem, then your mind should think of these two pointer technique, and that to the opposite direction pointer, right? So this opposite direction pointer works best for the sorted arrays, uh, because the increasing left pointer increases the sum as well, right? So whenever you increase the left pointer, it increases your sum as well, right? So I'll show you the template of this opposite direction pointer. Okay, the first variation. Let's move on to the board. Okay, so this was the basic template which we have seen, right? Now let's move on to the first variation, that is the uh, first variation, right? So we have total four variations. Okay, so four variations, so four variations, and this is very key content, right? So you have four variations in two pointer technique, two pointer template, or two pointer technique. Now we are discussing the first variation, right? So variation 1, okay, so it is basically opposite direction pointer, right? So in this, you will encounter the problems like to sum to. So basic template is like this. You have a while loop, right, and while some condition, right, while left is less than right, okay, then you will have sum. You need to take a sum. You will take int sum, okay, and nums of left, you will take the sum of nums of left plus nums of right. Okay, so and then you will check the condition. If sum equal to target, you will be given the target integer or target value. So if it's equal to target, sum is equal to target, then you will return your array. Return array. So basically it will be left comma right. Okay, so if if your condition is met, right, now again you will check if sum is less than target. If sum is less than target, so what you need to do is increment the left pointer, right. You will increment the left pointer, left plus plus, and then if it is not right, you will decrement the right pointer, right, minus minus if the condition is not met. Okay, so this is basically how this two pointer technique is. First variation, that is opposite direction pointers. So I've closed the loop as well. So this is how the first variation comes into picture. You are basically summing the value of nums of left plus nums of right, and you're checking if the sum is equal to target. Then you are, if the condition is met, then you return the array. If the condition is not met, again you will check the sum, and if sum is less than target, then you will uh, increment the left pointer, else you will decrement the right pointer. Okay, and then that's how you need to check this first variation, that is opposite direction pointers. Okay, now let's move on to the next concept. Okay, so basically the next concept is second variation. Okay, so we'll see that second variation here. Okay, so uh, that's what I told you, that this was the logic for the first technique. Okay, if the sum is less than the target, then move left. If the sum is less than greater than the target, then move right. Okay, so if sum equal to target, then the answer is found. This was the first technique. Now let's move on to the second technique, second variation, that is the same direction. And in this you have a fast pointer and a slow pointer. For this kind of technique, you will encounter the problems like remove duplicates, move zeros, right. So here you have two pointers. First one is fast pointer and second is a slow pointer. So the fast pointer scans the array, while the slow pointer maintains the position of valid elements. Once again I repeat, the fast pointer scans the array while the slow pointer maintains the position of the valid elements. Okay, so now let's quickly move on to the template of this variation, that is the same direction, fast and slow pointer. So quickly move on to this, right? So we are on the second variation. So it's basically the second variation here, variation 2, variation 2, that is the same direction, and that is basically having the 2 pointers. That one is the fast one and the slower one, and slow, right? So let's quickly move on to the template of this pattern. So you will declare int slow equal to 0, then you'll apply a loop for int fast equal to 0. Fast is less than nums dot length and fast plus plus, fast plus plus, right? So in this you will check, in this you will check for the condition if nums of fast, if nums of fast is not equal to nums of slow. So if it's not equal, then you will, what you will do, you will decrement, you will increment the slow pointer, you will increment the slow pointer, slow plus plus, right? And then you will maintain like this, nums of slow is assigned as nums of fast, right? So then closing the brace of if condition. So this is what the basically the second variation of the two pointer technique, that is the same direction. You have 2 pointers, fast and slow. So that you will check for the condition if nums of fast is not equal to nums of slow, then you will increment the slow pointer and you will assign the nums of fast to nums of slow, right? So this is basically a second variation. Now let's quickly move on to the third variation. This third variation is basically the sliding windows style, right? So in this sliding window style, you may encounter the LeetCode problems like longest substring and so on. So you, whenever you encounter the longest substring, then you should immediately think of the third variation of the two pointer technique, that is a sliding window style. Now let's look at the template for this third variation. We've already seen the two variations. Now the third variation here. So variation 3, variation 3, that is sliding window slide style, right? So what you need to do is here, you may encounter the problems like longest substring. So you have to apply a loop, you will apply loop while condition, while right is less than n. Okay, now In this, you will check while the condition here, and then you have to, if this is true, then you will add window.add of array of right. Okay, now you will again check for the condition here. If the condition is invalid, if invalid, then what you will do is you will remove the element from the window, that is window.remove array of left, right. So again checking for the condition, right. So if it's found to be invalid, then you are removing the element from the window, and then you will increment the left pointer, left plus plus, right, and then you will just uh, close the loop here, right, and if it is outside the loop, you will come out and say decrement increment right, right. So and you will just close the loop, outer loop. So this is basically the third variation of two pointer technique, that is a sliding window style. So in this, what you are doing is you're checking the condition while right is less than the n. Now if it comes out to be true, then you are adding that into the your window, that window dot add of arr of right, and again checking while the condition is invalid, right. So if the condition is invalid, then you will remove from the window array of left and increment the left pointer, uh, and then increment the right pointer. So this is what the sliding window technique, third variation is sliding window style. Okay, now let's move on to the next variation, that is the fourth variation, is basically the converging pointers, right. Now the this what we have discussed here, right. So fourth variation is the converging pointers. It is basically used in the palindrome, LeetCode problems and container with the most water. Okay, now basically you have to look for the time complexity. If you use the brute force, then the time complexity comes out to be big O of n square, big O of n square. Now the two pointer techniques give you the complexity as big O of n. So it is, once you recognize the pattern, many of the interview problems will become almost identical, right. So you have to identify the problems. Now basically the interview is asking for, is expecting for the complexity as big O of n. So that's what you have, you should look for every time. Now let's quickly look on the template for the fourth variation. Okay, so here comes the fourth variation. We have already seen the third one. Now the fourth one is like this. So variation 4 is basically the converging pointers, right. So variation 4 is the converging pointers. Okay, now in this, I've already told you that you will encounter the problems like palindrome, container with the most water. Now the basic template for this converging pointers is basically you will apply a while loop, while, and then left is, you'll check for the condition while left is less than right, and then you will check, you'll apply check if s dot caret of left is not equal to s dot char at of right. So if this condition is true, then what you will return false, return false, right? Okay, now, and you will increment the left pointer, left plus plus, and decrement the right pointer, right minus minus. Okay, so and we'll close the loop. So basically this is what is the converging pointer technique here. Now you're checking you're applying the condition in the while loop, while left is less than right, and then you are checking the condition like if character as s dot char at left is not equal to s dot char at right. So if that condition comes out to be true, then you'll return false. You will increment your left pointer, you will decrement the right pointer. So it's what the converging pointer technique here. So it's a fourth variation. Okay, now let's see more things. Now, that's what here I've told you. Now, why the two pointer technique is most powerful? Because whenever you apply the brute force, you will come to the time complexity as big O of n square. Now that is not expected from uh, in the interviews. So you have to maintain, or you have to come out to the solution that gives you the complexity as big O of n, and that's what the interviewer is expecting from you. So once you recognize the pattern, then many of the interviewer questions will become almost identical to you. So that's what you need to do, practice for these problems, so that it becomes much easier for you. Now, uh, so these are the very common interview questions that I've been telling you: to sum to container with the most water, valid palindrome, remove remove duplicates, move zeros. All these fall into the two pointer technique category, and then you have the different variations that we have already seen that needs to be applied on these problems. So here the thing is that in this you need to uh, you need to go on to the four variations very nicely, so that most of the lead code problems becomes much easier for you. Now in the next video of this series, we'll cover the sliding window pattern, which is one of the most powerful technique for solving the substring and subarray problems. Once you combine the sliding window with the two pointer technique, you will be able to solve many of the medium and hard lead code problems very easily, very easily. Okay, so if you're preparing for the coding interviews, you will we will cover if you say that if you are preparing for the coding interviews, make sure you subscribe the channel, because in this playlist we'll cover all the major coding problems in Java. uh, that is basically used by the FANG companies. Okay, also check the playlist in the description. Okay, so you can follow the series in the correct order. So that's what the two pointer technique is, right? So do subscribe the channel. Okay, thanks for watching this video.